Guys, my name is Mihai John. As you know, I have a couple of videos. I'm not looking to be professional, but today I want to talk a little bit about different about the life and the reason why I'm doing these videos and the reason why I don't want to make money on YouTube and I don't care about advertising or getting rich or buying 20 million homes to stay at home where when other people are struggling. I'm not very financial orientated person. I believe one day we'll all die, and every single monkey which think that he'll become rich by exploiting people is nothing but an idiot. It is quite painful for me to say that this is a place under the sun, a little town called Galati. It is in Romania. Here, my parents give me the birth. They work here. My grandfather worked here. A couple of my friends died in there. And they build a kind of society which, even if it didn't work perfect, we survived. We breathed these gases. We died, and now after the revolution, people took big advantages. Big corporations from outside came with a lot of money. They bribed the government. They bought the factory for almost nothing, and now the people on the government have all these criminals which bought these factories have more money than people in the Western countries. They live in the yachts and luxurious life beyond your beliefs. And now, when you'll ask me why I came into your country to work, why I'm taking your job, you have to think. If someone destabilizing other countries, the surviving desire in your heart will make you to run away. Before you make any comment, please search for the truth. As you'll see that big smoke and all that factory I show you, we breathe all that gas and we die there and we work there, and some people come from outside with a lot of money bribing the government, buying that factory for nothing. They fired thousand and thousand and thousand on people to make that factory efficient, and now all these people are coming into UK, in France, everywhere. So please, when you talk about migrants, just think about and do some research. Now I want to tell you my story. I came in UK as an immigrant, and I start from the rubbish bin till where I am today. I had some choices to become a junkie, to live on benefits, or to work shoulder to shoulder with British people to try to leave this country. Unlike the rich corporations which are stealing from people and betray the people of this country, going in other countries to make businesses. I'm working here. I'm paying money for the education here. I'm not building homes in any other country. So I think sometimes I'm much more English than some English will betray this country. This is all I want to say. Anytime you design a programmable logic control, you have to understand what is the uh, logic control, what is used for, and then you create your own testing board. And if you look, this is my testing board, and you'll see it in the end. The great benefit of being hands-on tools is that you'll understand a lot of technology, but then you have to be very careful because our beloved government destroy English education, destroy the factories, destroy the technical education. Everything come from China. I don't hate the Chinese people. I just hate this government because they do not facilitate and encourage the people from UK to learn electronics, to learn to create things. Look, even Maplin disappeared. Nobody buy a transistor. They don't even know even how to use it. Do you know what would really happen if sometime the Chinese will not supply semiconductors and stuff? Coming back to my story, I designed this platform to check a printed circuit board. This is a handwork, it doesn't look good, but I know everywhere wire which is go. So when I finish that system, this is the testing board I built. It's got analog inputs and outputs, it's got digital inputs and outputs. So in my life, if I have a problem, I can repair my boiler, I can repair my car, I can change all the lighting in my home, I can repair my electronic watch, I can repair my PLC, I understand how the CPU works, I can build my own computer. And I think it is time for us, people of UK, to wake up, but not in an angry way, to look in the mirror and to look, are we animals who buy everything for free? We really have to learn how to create our own technical world. That's why the English ancestors died, not for everything that happened today. Now, I love my son. I really love my son. And I try to educate him and to give him a chance. I show him how to write programs and how to visualize an air handling unit or any other control, how is it working. But now I want to come back to my problem, air handling units. Today, I want to explain to you how the air handling unit works, but I'm going to zoom into the heat exchangers. If you want to see more, I have more videos about the air handling units. Well, if the YouTube is not blocking me. So let's start. The air to be cooled, it must pass through some heat exchangers. They are inside the air handling unit. And now I will show to you step by step how the temperature and the heat exchanger's capability to remove the absolute humidity will affect the air. Now, if you look in this picture, you will have the air handling unit configuration inside. I didn't attach the frost coil and the humidifier. I'm not interested at this stage. I just want to explain to you how the air is affected by the cooling coil and why the heating coil fights sometime against the cooling coil when you want to dehumidify the air. What you will see with the green, red, and blue color, it represents the air and its ingredients. When the air comes in, it got a humidity charge, the grams, the kilograms per meter cube. It's got a temperature, which is measured in Celsius or Fahrenheit. Also, we have the relative humidity, which is reading that changes with the temperature. Unlike the commercial environment where you're going to take advantages of the fresh air, in the pharmaceutical industry, we recirculate 90% of the air and we will allow the fresh air intake to come inside only 10% and will exhaust 10% of the air to balance the fresh air intake with the exhausted air. And we're doing this because the recirculated air passes by through HEPA filters and the air is very, very well filtered. We would not like to lose the air property or to contaminate the HEPA filters very fast. In this situation, I have a demand in the production room that matches exactly the cooling capacity of the unit by not running the heat exchangers. The fresh air intake have a perfect temperature and relative humidity to match the demand inside the room. Under this condition, the air will not suffer modification and I have a perfect value to the air that reaches the room. This is the most economical way to run an air handling unit, but unfortunately we cannot control the nature. That's why we have these heat exchangers. Now the production area is asking us to provide 18 degrees Celsius and 50% relative humidity. Now I will only have to drop the temperature without disturbing the relative humidity. How would that be possible? The fresh air conditioning cooling coil will be activated by the actuator, which get instruction from the programmable logic control. And the programmable logic control will read data through a sensor that is fitted inside the air handling unit. So now, as you will see, the cooling coil been enabled and the temperature start to drop. But because the cooling coil has not been cooled below the dew point, we dropped only the temperature without removing moisture from the air. So when the air reaches destination into the room, I will have 18 degrees as demanded, but the relative humidity will go higher. Now we have to rectify this problem. Let's see what can we do to make it right. Now we learn from our mistakes. If you look to the left hand side bottom, you'll see we have 25 degrees on the fresh air intake, and also if you look to the absolute humidity, it is higher than the absolute humidity after the air passes the heat exchanger. So here's the trick. We'll remove moisture from the air, so if we'll drop the temperature, we'll have the same relative humidity. This is a very important thing for you to remember. You have to cool the coil below the dew point. As you will see, the little blue arrow underneath the heat exchanger, that means we eliminate water. That's why I just colored it in blue. So you see the drain is active, and by removing moisture from the air, if we lower the temperature, we'll have a constant relative humidity. This is something very important. So now you reached the temperature and you have a good relative humidity, then the coil capacity will be controlled by the actuator. I constantly repeat that we cannot control the nature. Now if you look down on the left hand side, you will see that the temperature remains constant outside, but then we have a surprise. The relative humidity raised at 75%. So the absolute humidity rose from 0.012 to 0.017 grams per meter cubes. Let's see what should we do so we can control the relative humidity and the temperature not to have trouble down the line. Look to the red arrow immediately after the primary cooling coil. As you'll see, the absolute humidity there, it is lower than the one which is outside, and that's the secret. We have to keep the absolute humidity and the temperature constant. That's why we'll have a constant relative humidity. Under such condition, the PLC will instruct the actuator of the primary cooling coil, which is the fresh air conditioning cooling coil, to go very cold below the dew point and to remove as much water from the air as possible. But then we can have some side effects because the coil is not only removing the moisture from the air, but also it is cooling the air. Exactly as I suspected, if you look to the right hand side down, the air it lost 1 degree and the relative humidity has been increased. So what can we do to bring the temperature back to 18 degrees? I think most of the people know. The PLC will instruct the actuators of the heating coil to turn the heating coil on. But I want you to remember, this is a PID. It is not 0 and 1. It is from 0 to 100%. You can choose any value to have a constant cooling and not to have an up and down, so you can use the average. So you do not use a differential as an average. So turning the heat exchanger, heat exchanger on was nothing but subject to anticipation. It makes sense. If the air drop and I still need the primary cooling coil to run, I have to compensate the temperature loss. And how can I do this? By turning on the heat exchanger. But as I said before, this is a PID. In a couple of moments, the temperature will come back to 18 degrees and everything will be reestablished. We have a good temperature and we have a good relative humidity. Exactly when we're preparing to go home, the nature hits again. So this time the temperature raises at 34 degrees Celsius and we have a relative humidity of 75%. Well, normally the PLC should be able to overcome the situation. So let's see how the PLC will control the situation if the program downloaded into the PLC, it was correct and it was done by a person which understands about the relative humidity, absolute humidity, and he told the programmer how to write the software. As the temperature increases, we do not need the heat exchangers at this stage, because as the temperature increases you will come to the point where the primary heat exchanger will reach the threshold where we barely can cope with the cooling and drying process. If the temperature increases more, the primary cooling coil, which I mean the fresh air intake conditioner, does not have the capability to cool the air enough. That coil will be very busy taking the moisture from the air. And as you'll see here, inside the chambers, the yellow color means the air start to warm up, and that's not a good news because the air start to be hotter and that can heat up the rooms. The sensors that are fitted onto the air handling unit will sense the high temperature and will send the information to the programmable logic control, the PLC, or some people are using BMS, Building Management Control. So this PLC will enable the actuator of the second cooling heat exchanger, and it will allow the cooling agent to pass by until the heat exchanger will cool down just above the dew point. As you will see, the arrow underneath, it is colored in red. So that means there's no water pouring from that drip tray because the coil, it is cooled down, but it is still above the dew point. This is happen if the system it is well designed and perfectly calculated. If the engineer took in consideration the 34 degrees and 75% relative humidity, then the system will be capable to cope with that demand. If the engineer miscalculate and they have a smaller heat exchangers, then we're in trouble because we might have to cool the second cooling coil below the dew point, and then we have to use the humidifier to compensate the lack of humidity into the air because we take too much moisture from the air when we run both coils below the dew point. Unfortunately, under the economical stress, some companies breach the rules, new technicians come at work, and some people with very generous ideas will start doing things which affect the AHU. So if you look at these air handling units, we have 34 degrees Celsius, 75% relative humidity, but the building has been increased. So a very generous engineer decided to bring more fresh air from outside, disregarding the fact that if we bring more fresh air from outside, the speed of the air through the coil will increase and we'll have less capacity on taking the moisture out of the air. Also, we have less capacity on cooling the air. So this can lead to serious troubles. This is something a little bit complicated. I will not talk too much about it, but I just want you to know some building uses multiple air handling units, and these air handling units have the capabilities to bring a lot of fresh air. This AHU does a section which receive indirectly a lot of fresh air from the other air handling units through the door cracks and some other gaps in the walls and so on. Because of this, the fresh air intake conditioning cooling coil, it is redundant. That's why I painted in black. So it is not used. Because of this, you lose a cooling and drying capacity. And working for a factory, I did a crazy things to use that coil. I took a part of recirculated air and then I recirculate the air through that coil as well. So I would gain more capacity on cooling and taking the moisture out. But that was not the appropriate action. However, it was a desperate one, and paradoxically, it worked. Because the fresh air intake conditioning cooling coil has been made redundant, the main cooling coil took the double function. Now it's got the duty to cool the recirculated air, but also it has to control its humidity. That it is possible, but there's a little problem because I do not have a buffer. The relative humidity and the temperature will be very hard to control. So I have to use an average of this temperature, and to keep a straight line when I'm following the trend will be extremely difficult. There is the opposite side of that situation. Some air handling unit take 100% fresh air from outside, and sometimes the cooling coil it is not well calculated. As you will see in this picture, I have to use both heat exchangers as coolers, but also I have to run them below the dew point to remove moisture from the air, because if I'll suck 100% air from outside sometime in the summer, the air is very humid and one coil does not have the capability to remove the moisture, so I could reach the set points into the clean rooms. Especially working for pharmaceutical industry, this is very severely controlled. Running both cooling coils below the dew point will remove an important quantity of moisture, but there will be a side effect. The air will cool very badly, and then we have to start the heat exchangers to compensate the loss of the temperature of the air. As the units are not upgraded or maintained properly, but mostly upgraded, sometime we might have the bad surprise. So the heat exchanger will be overwhelmed and they won't be able to provide enough capacity to cool the premises and to dry the premises. Well, then it is when the real problems began and there's nothing you can do. So this was the story about the air handling unit, which must run through two heat exchanger. One it is the fresh air intake conditioning heat exchanger, and the other one it is the main heat exchanger. So the main heat exchanger will cool the preconditioned fresh air and also will cool the recirculated air. So this is the AHU, which has got two coils and recirculates the air. Now let's go worse. Let's go for one air conditioning, one air handling unit, which takes air directly from outside, 100%. There's no option to recirculate the air because it doesn't have that feature. So I have to take from outside 100% fresh air and to exhaust 100% fresh air. And obviously, I have only one cooling and one heat exchanger. This heat exchanger, it is built so the HVAC engineer will pay for every single scene he did in his life. This air handling unit sucks air from outside 100% and it's got only one heat exchanger. for cooling and one heat exchanger for heating. To control the relative humidity and the temperature within a very narrow bandwidth, it is an impossible task almost. And I'm dealing with this type of air handling unit right now. So I'm doing a control assessment to see how sensitive the actuators are, how the PID it is set up, and where the probes take the information in relation to the temperature and relative humidity. As you will see here right now, the air, let's say it's perfect and no heat exchanger is running. We have a perfect air and the room is properly cooled. The worst situation it is when the outside temperature and relative humidity start varying. That it is a moment when the brain overheats itself like a computer which has multiple tasks and the processor it is not big enough to comprehend all the instruction given by a lunatic which presses switches continuously. If you can imagine, if the room will demand 18 degrees and 50% relative humidity, and outside I have 34% and 34 degrees Celsius and 75% relative humidity, the absolute humidity outside will be 0.028 kilograms per meter square, per meter cube. I do apologize, meter cube. Maybe my head is square. And from 0.028 I have to drop the absolute humidity to 0.008 kilograms per meter cube. To do this with one heat exchanger only, considering the air flow it is very high and the speed of the air through that heat exchanger is massive. I think somewhere there's a mistake, it might not even be calculated, but to drop that humidity only in a glint of an eye, because the air only passes once through that coil, I have nothing recirculated so I can use it as a buffer. It is almost an impossible task. If you look at this trend, what I could possibly do is just to ameliorate a little bit the valve aggressiveness and to smoothen a little bit the trend. However, I am not happy with this because if I have a very abrupt raise in the temperature one day, the temperature and relative humidity will reach the sky. So this is a dangerous situation in which I have to reprogram the programmable logic control to get proper instructions that will involve the outside temperature as well. What you will see here, this is the outdoor temperature. So I'm collecting data from the outside and I compare data with the temperature after the cooling coil because I want to evaluate somehow the cooling coil capacity, considering that the airflow which passes by is much higher than the capacity of that cooling heat exchanger. And the only way to evaluate this situation it is to use data loggers. Because the data loggers will do a trend and then you compare both trends and you can see how much you can work on the system and what type of adjustment you have to do. If you looked at this trend, outside was quite steady temperature and I tried to have a steady trend. It might look reasonably well. As you'll see, the temperature is not very much disturbed, but the relative humidity goes like a yo-yo up and down because my coil have the capability to control the temperature but does not have the capability to control the humidity because the coil might not go below the dew point. I just looked the drain and it was perfectly dry. So this is about the AHO. On the other hand, what can I tell you? I'm doing some rooms assessments about, I'm checking how the air is moving through the rooms, why the people are not happy, why I have such difference in between some corners of the rooms, how opening the door it's affecting the sensors, how two doors open create a tunnel in which I'm losing a huge quantity of air, and so on. So thank you very much for listening for my blah blah blah, and I do apologize again for all the mistake I do when I'm speaking this wonderful language, but probably this YouTube will really help me to improve my English one day. Thank you so much. Have a wonderful time.
When you really want to learn control, programmable logic control, and electronics, your life will be like that. You waste a lot of time, and to understand clearly how a PLC works, you have to do analysis for every single input and output to see how the PLC works, and hell of a lot of stuff to read. Then you can build a control board to simulate your programs on a PLC. As you'll see here, that's the back side of it, all right? Now, if you'll turn it upside down, turn it all right, the switches. So every input that goes into the switch will light this switch. And when you press the switch, you can simulate faults. Also, there are switches, there are a potentiometer, which allows you to raise up and down the voltage to the PLC analog input, and the PLC will respond to the input, enabling an output that will activate one of this. Why I'm using colored switches? Because I'm going to give them name, like this is the fan, this is the heater, this is the, this is the fan, this is the cooler, this is the heater, this is the defrost. But I'm a HVAC engineer. This cannot be used only for the HVAC. It can be used for everything which you need to control it. So sometimes it's not enough to be a programmable logic control or a programmer, PLC programmer, to understand how a process works. Sometimes you have to understand more than that. And when I'm talking about this, you have to understand the process. So that's why I'm building this testing board, because I want to create a program which controls a HVAC equipment, economical, which can read from the boiler data, and technically you can write a program for everything. But this board helps you to simulate your program so you don't make mistakes before you'll put the program in a market. How can I say? I don't want to reinvent the wheel, but I found so many mistakes, and I just try to do best. Anyway, your life become like that, and I don't think your family will be very happy, because I don't have a garage to do this job. So now the show starts. I have to remove the TV fascia. As you'll see here, you have some little screws. I have to turn the TV. Then I did the full assessment. As you'll see, I moved it slowly, and I just find out that there's another LED which starts